Okay, good evening, everybody. So today's topic will be on matrix resurrection. We will talk about matrix and the change from the imperial system to the matrix. They call it imperial system because last time is the British system. Is there's a queen, so it's called imperial system. Okay, so we start with a very brief history. So this agreement was signed between a number of countries, like 18 countries. So they signed this in Paris. That's why they have a French name, Systeme Internationale d'Unités. In short, they call it SI units. So in these SI units, the most important two things are the length and the weight. Okay, because at that time, 1875, they are not so advanced like in today. So after more than 100 years, like 150 years, we have almost every country had adopted the SI unit. The only few countries, main one is US. US is still not fully using the SI unit. You can see for almost all their invention, like the floppy disk, they put 3.5 inch, 5.25 inch, 8 inch disk, and so on. And then everything in US like on the road, they also use the miles, and then got miles per hour, and then they use acres, they use feet, inches, and gallons. When they buy water, they count by gallons, and the weight they go by pound and ounce. So UK is also very similar to US, but they are improving now. But US, I doubt things will change in the very short term, because until today they are still talking about degree Fahrenheit and all the miles and all this. So they will never change. All these are used by the majority of the people. In the US political system, nobody want to do the dirty work and all these things that make people unhappy when you change from imperial system to the matrix system. During the changing stage, it's very confusing. Just like when Singapore changed from imperial system to the matrix system, you notice that the road sign, the speed limit also has to change to different shape. Otherwise, how you define 50 kilometer speed limit and 50 miles speed limit? I mean miles per hour and kilometer per hour. So it can be quite confusing for people. So Myanmar already started in 2013, but until now they are using matrix and the imperial system plus the traditional ancient Myanmar system. So also don't know what type of system. So some people still use that. Similarly, like in China, they still use some traditional system, like when they count the area of the field, they call Imu. Then like 1 acres, 1 acres is approximately like 6 mu. It's like 6.07 mu. So it's a bit confusing sometimes. But traditionally people, if you don't educate them, they will continue to use the traditional way. And even you look at Singapore, people still use square feet. And then sometimes they go by acres. 1 acre is approximately like 40 meter by 100 meter. It's like a football field size, so it's easy to use. So you notice that Singapore, when they buy screws, sometimes they go by inches, and the olden days when they buy cloth, they go by yard. 1 yard. 1 yard is about is 3 feet. It's almost like 1 meter. 1 yard is close to 1 meter. Difference of 3 inches. Okay. So Liberia is, because it was a US colony, so of course they follow US, but they are more ahead in the SI unit than US, because they don't care about US now. They do their own, and they are going into metric system. Eventually, if US don't change to metric system, they will lose out. But because now they are very strong in economically, so people still support them in the imperial system, like the size of the screw and all these things. Okay, so the SI units, basically they have these 7 definition. Okay, the first one is the time. Time in seconds is obvious. You have been using your time all along. So above second will be minutes, hours, days, weeks, months. Months a bit confusing. So some months have 30 days, some 31, sometimes 28, 29. And then you have a year. The year also may not be fixed. So this main thing is the seconds. For engineering purpose, they only use seconds. So seldom there's a requirement for minutes and all these things. So those minutes, hours are normally used by laymen. They did try to think about changing the seconds and minutes to round numbers like 100. Let's say 100 seconds is 1 minute, something like that. But probably they have to use a different word for it. But it's not popular. You can't change people's mentality. Everybody is used to 1 second, and 1 minute is 60 seconds. And if you want to change to 100, they cannot divide. You cannot divide by 3. 1 minute, how to divide by 3? If you make 100, let's say 100 seconds, how you divide by 3? And it's very difficult. That's why you find that a lot of measurement in the imperial system, whether in China they have 1半斤8两, is half a catty is 8 taels. So is in multiple of 8, and there's some there's 6, there's 12 lah. One feet is 12 inches, and then 12 is very good because you can divide by 2, 4, 3, and 6. And then when they go to seconds and minutes, 1 minute 60 seconds. So 60 seconds can divide by a lot of numbers, divisible by 3, 2, 4, 5, 6, and so on. So it's a very easily divisible number. So 60 is a very fantastic number. Then the next one, important one, is the length. Length will be, in metrics, is called the meter. Then you have mass, then electric current, they call ampere, and temperature is Kelvin. Of course, you can say Celsius. Celsius and Kelvin is equivalent. Okay, and then the next one is the amount of substance. This is defined as mole. 1 mole has a fixed number of atoms inside, so it cannot change. Or molecules. 1 mole has a fixed number of molecules. So this is a fixed constant. Some scientists when they do experiment, they discover it's like that. And then the luminous intensity is called candela. You hardly hear people talk about candela, but you heard like lux and lumen. Okay, later we explain all these things. And not included in this SI unit, and it's very important, is the angle. Okay, which is a degree and radian and gradient. A lot of people have not heard of gradient. Few people heard of radian, and everybody know degree. Okay, we start from the angle first. Okay, this degree is one circle. One circle, you go one round, one circle is 360 degrees. There's nothing to define. You don't need any definition. Everybody know, oh, 360 degrees. You turn one round, 360 degrees. Half around, 180 degrees. So it will be exactly 360 degrees. You don't need to define. Everybody in the world turn one round, 360 degrees. Nothing to that is a standard. It's already a standard, one round, one circle. So radian is also one circle is radian 6.283 about. So it's based on 2 pi, because if you have a circle of 1 meter diameter, then you go one round the circumference, you got 6.283 meter, one round. You get 1 foot of radius, then you get 6.283 foot. So radian means is the angle, 360 degree one round is 2 pi radian, because the circumference of a circle is 2 pi r. R is the radius of the circle. So if r equal to 1, then you have a 2 pi radian. So that is called radian. So for normal layman, it has no meaning. It's very difficult to use what radian and all these things. But in engineering, it is very important. And in trigonometry, maths, physics, radian is very useful. The next one is the gradient. Gradient is even rarer, even fewer people use. So far in school, we never use gradient. We never thought about this thing called gradient. It is supposed to be one round circle is 400 gradient. But if you use some scientific calculator, you can change from degree to radian. You can also change to gradient. So you can try that out if you have those scientific calculator. Why is this gradient? Because people thought if I make one circle 400 gradient, is a round number, it's easier to use than 360 degree. Because you divide by 2 is 200, divide quarter is 100, and then is multiple of 10. So 400 is a multiple of 10 times 10. So because when you go matrix, everything is 10. Millimeter, centimeter, then the next one is called decimeter, and then meter, and so on. So everything is 10, 10, 10, 10, 10. So they try to make a circle 400 gradient, but it's not popular, and then nobody use. So this one actually fear. Okay, before we talk about all the metrics, it's good to understand what all this angle means. So another thing about angle is they call stir radian. Come from the word radian at the back, radian. So the one stir radian is a solid angle. It is not 2 dimension, it's 3 dimension. So it is like 1 meter radius, and then it has on the surface of the ball, it has an area of 1 meter square. So that particular cone, if you do a cross section, you get about 65.54 degrees. There is one stir radian. It's a solid 3D angle. it is not a two-dimensional angle. So this one is important when you talk about lighting or sound. When sound travel, it goes round. That's why when the volume of the sound will drop in the square of the area. So if you go twice the distance, the sound volume will drop 4 times. Okay, same for light. If you double the distance, the light intensity will drop 2 times. You triple the distance is square lah. It's always square. So square of the distance. So it's the same like your Wi-Fi signal or your phone transmission. Once you double the distance, you hold the phone away from your ear, the amount of radiation that gets into your body will be reduced according to the square of the distance. So that's why when you have a Wi-Fi, it drops very fast when your distance increase. When you increase your distance, the Wi-Fi strength drop very fast because it goes by the square of the distance. Okay. So now we come to the main thing about SI unit. The very important one is the length. If they cannot get the length right, then the rest no need to talk already. So in order that everybody in the world understand what is 1 meter, then they make a piece of platinum iridium rod. It is actually they purposely choose this material because it's highly anti-corrosion. It don't corrode, but of course dust will settle on it. So if there's a dust, then when you try to measure, you measure the dust as well. Although it's very minute. To us, you just take a ruler and then you measure 1 meter. That's good enough. But in engineering, in precision engineering, you cannot do that. See, so you got to buy those special materials, special things, a measuring device. Actually, it's metal pieces where is machined until very precise and very flat. So flat that 2 pieces, if you put them together, you squeeze a bit, and it will hold like magnet like that. You hold one on top of the other. It will not drop. You can join them up. So they are very extremely precise, but they cannot. Everybody use this as 1 meter. But this particular piece is very precious. Once they make it, it's only for reference. You cannot anyhow take and use, because once you use it, you wear out, and then it's not accurate already. So you can find it in the museum. Okay, then of course for that piece of metal, they made a number of copies. So they have a master copy, and then they have a reference copy for distribution around the world, maybe only like 8 pieces only. So it's very precious. Then from these pieces, they produce other references that is also very accurate. Then from that pieces, and then so on. By the time you reach your ruler, it's not accurate. But for us, you miss by 1 mm, 2 mm is okay. So it doesn't concern us. But if you are doing precision engineering, then it's very important. Let's say your motor car piston, if you produce the piston and then another person produce another piston, and it's not exactly machined exactly the same, then you find that it doesn't fit. Then how you cannot mass produce from different places, and you cannot sell or interchangeable and so on. So it must be very, very precise. Okay, so a little bit on history. Like in 1892, this person, Michelson, he used this interferometer. This one is based on the light, a machine that do some light reflection, because light is a wave, just like water is a wave. So if the wave of the light interfere with each other, it cancel out. If they come together, then it enhance the light, such as similar to laser lah, but it's not exactly laser. Is that then the two phase of the light come together, you get a brighter. Then you can see the light in different, like zebra line, one line. Then you count and you get 1,553,000 and so on. And that is exactly the length of 1 meter. But why they use a light instead of that metal piece? The problem is that metal piece, there are only a few masterpieces, very difficult to design, very difficult to machine, and you cannot always take it out and use it. And then it must be used at the right temperature. If at the wrong temperature, too hot or too cold, there will be a slight difference because metal expand. And if you want accurately, you just cannot take reference from another piece. So, and not everybody can get hold of the masterpiece, and they won't let you do that also. So it's easier to define the meter based on the wavelength of the light. So you take the wavelength and you count how many million times, 1.5 million times, and that is about 1 meter. And any scientist with certain good enough skill, they can do that. So you don't need to touch that piece of metal. You can create this cadmium, and then you get the red line and see the wavelength, and then you count how many wavelength, and then you get the exact 1 meter. So that will be very accurate already. Okay, but then they also find that in 1960, another person recommended krypton light, which is a smaller wavelength. So you need more wavelength, about 1.65 million, to get the exact 1 meter. And furthermore, it must be in vacuum, because if it's not in vacuum, light travels slower. The wavelength they lose energy. And then in 1964, they use a helium neon as a light source to count the wavelength to get 1 meter. Then they change again to use iodine to stabilize this laser wavelength. All these are very scientific, but eventually they decided to define 1 meter as 1/299792485 seconds, the light travel. Because light travel about 300 million meters per second. So you divide reciprocally in that amount of second, light travel 1 meter. So you don't care already. You don't care what wavelength, all these things. You just measure the time and the distance the light travel. Okay, that's 1 meter. That's the definition. For people like us, I give you the light. There are plenty of light, but you can't even get 1 meter from the light. How to know 1 meter from this light is beyond us. Okay, but all these are definitions, so it will be correct everywhere you go. Okay, but to us, all those things, how they define meter, all these things is not important. These are scientific definition to standardize the length of the meter. So they need to standardize, the whole world need to standardize. Then it'll be easier for production. When you want to produce things or want to do scientific research, you want to measure the weight of the atom or the length of the size of the atom, and or whatever thing you want to measure, it is standardized across the whole world. Okay, but the problem, people wondering why they choose 1 meter is they don't choose 1 yard is 1 meter. That would be easier, right, if they had chosen 1 yard. But unfortunately, when they decide how you can get 1 meter, they must find something in this world on Earth that is fixed. Then you can get a definition of 1 meter. You cannot be based on the emperor's leg, arm, height, or what, or some object that can change. So they choose the Earth. So you go one round the Earth is 40 million meter. That's what they define, because they know what's the size of the Earth. So they calculate like that. Then, okay, it work out 1 meter is almost about 1 yard. 1 yard is 3 feet. But there's a difference of 3 inches. So to them, it's good enough. See, so, but if you go around the Earth, you go around the North Pole, go around the equator, or any other part, is not always exactly the same 40 million, because the Earth is not exactly round like a ball or marble. There are mountains, there are holes, and many other things are building. You dig one big hole here, and water, and the moon, gravity, you got high tide, low tide, and all this. So it's roughly around there. So that is a good definition for a meter. But of course, people cannot use the Earth as a reference. From there, you get roughly the length of the meter. Then they physically fix it using one platinum rod, platinum iridium rod. And then they say, okay, now everybody follow. This is the 1 meter. Okay, that's all. So they got it 1 meter. So why they choose 40 million meter? Because they were thinking they want to use gradient. So they divide the Earth into 400 gradient instead of 360 degree. If they had chosen the one round the Earth is 36 million meter, then that would be easier, right? But instead, they're going to choose 400 gradient. If they had go back in time, probably they will decide to change to 36 million meter, go around the Earth 1 round. The reason is 400 gradient is very difficult. When you go to school, you do Pythagoras theorem, you have a 30 degree and 60 degree. So you have a right angle triangle of 30 degrees and 60 degree. A right angle is 90 degrees. Then you have a Pythagoras theorem, you got 1, 2, square root 3. But 30 degrees is how many gradient? It's not a round number. It's very difficult to use. So it's never popular. So you end up with miles. Miles is the imperial system. And then you have the kilometer, which is the metric system, because they use the 400 gradient. And then you still have the nautical miles. Nautical miles is based on the Earth, 360 degree. So, and then they go by a minute and degree. 1 degree is 60 minutes. So, end up 1 nautical mile is about 1.86 kilometers. Then, if they had make the metric system based on 360 degree, they would have gotten rid of the nautical miles. But now nautical miles still remain, because in the sea they prefer nautical miles, but they can see how many degree they can move. Okay, so now you look at the imperial system. It's very confusing. 1 mile you got 8 furlong. Some people they don't even know what is furlong. And then what is chain? They only know gold chain. And then 1 furlong is 10 chain. And then 1 chain is 22 yards. But why they choose this odd number like 22? Because they find that as they go higher and higher, they have a chance to use odd number, like divisible by 11. Otherwise, they want to divide by 11, cannot divide. So now they can divide by 11. So 1 mile, you can divide by 11, and then you can get how many feet. You see, so it is possible lah. And then divide by 5 also can already, because there's a 10 chain. So you can divide by a lot of numbers extra, like 11, 5, which are very, very odd numbers. Okay. So in even in Singapore, last time they buy cloth, they say jiba is 1 yard. So they always measure yard. And when you buy them, Abbas them buy in a meter, they still measure in yard. So you actually gain extra 3 inches. Say 1 meter is say $3 for cloth. Then they measure in yard. Then you get 3 inches extra for 1 meter of cloth. So 1 yard is 3 feet, which is close to 1 meter, and 1 feet is 12 inches. Remember last time when I was in university, they gave one exam question. They say this magnetic tape, 9,600 beats per second, BPI, no, beats per inch, beats per inch. So the tape, when you run the tape, it runs 9,600 beats per inch. And then they say this tape is 100 feet long. Then how to convert? Wow, look, some people blur. They say, how you convert what is BPI? Oh, beat, even if they know beat per inch. Then what is 100 feet? Is how many inches? They don't know. If they look at the ruler, they see 12 inches. They could have guessed that, and then maybe they got it right. But because they are younger, especially the girls who are a bit younger, they don't learn inches. They don't learn the imperial system in school, so they forgot all these things. Whereas for us, we still use the imperial system in primary school until secondary school. Then they switch over to the metric system. So we learn both systems. So if you look at when people talk about 1 acre, 1 acre is actually 66 foot times 660 foot. So, and then this is about 40 times 100 meter square. So it's 4,000 square meter, about there. So when people talk 1 acre, we always think it's like a football field, 40 meter times 100 meter. But actually, it's not exactly that. So if based on this imperial system, 1 square mile is how many acres? Headache, right? So you know how hard it was when we were in school. So now you go into the matrix. Matrix is very easy. You have a millimeter, and then you have the centimeter, and then the less often used one or rarely used is a decimeter, then followed by the meter. Each one you add a zero, and then so on. So 1 meter is 1,000 millimeter, 1,000, and then smaller than millimeter is nanometer, micrometer, then nanometer, and then pico and so on. So it goes smaller and smaller, but it's beyond yeah. Somebody asked 1 meter is longer than 1 yard. 1 meter is 1 yard 3 inches. Oh yeah, just now I was saying you buy cloth 1 meter. They give you 1 yard, which is wrong. It should be 1 yard 3 inches. So 1 meter is 3 foot 3 inches, about there. Okay, so when you talk about metrics, then we will look at the paper. We always use the A4 paper, and then you find that it has a very odd size of 21 cm times 29.7, about this size. But why they choose such an odd number? Whereas you use the normal, by default, your printer driver will give you the imperial measurement. They call it letter size, which is 8 inch by 11 inch. So it's very straightforward, 8 and 11. Why did we make our A4 paper at this funny shape? See, it's not a round number, but they have their reason. So you find that your A4 paper, if you fold into half, you get A5. Then you fold again, you get A6. But if you take two A4 paper put together, you will become A3. And then you put two A3 together, it become A2. You put two A2 together, it become A1. You put two A1 together, it become A0. Okay, and now is the definition for A0. A0 is exactly 1 square meter. So that is the size of A0. And then based on that, and they also want the paper to be very easy. You can take one A0 paper and then you cut into two, you should get A1, 2 pieces of A1. But how to do that so that it will appear like in this diagram? So in order to do that, you must have a correct ratio. The X and Y of the big paper is the same as the 0.5 Y and the X of the small paper. The ratio must be the same. And based on this ratio, you do your maths, you'll get the ratio of the length and the width. And based on the ratio of the length and the width, for A0 paper is 1 square meter, then you get the length and the width of a A0 paper. That's very easy. And then when you buy paper, you find sometimes they say 80 gram, 70 gram. What's the meaning? Why paper is 80 gram? But you take a A4 paper, you measure it's only about 4 gram plus. How to 80 gram? So you realize that if you take the paper of a A0 size, you will get 1 square meter, and that is exactly 80 gram. So if you become A4, that means it becomes 16, divide to 16 times. So you take 180 gram divide 16, that would be the weight of 1 A4 paper. So if it's a 70 gram paper, then you divide by 16, you will get the weight of a A4 paper. Okay, so this is how the A4 paper come about with this size. It's not a plug from the air. Okay, now the next most important is the weight. Many people are confused between weight and mass. Okay, but they are used interchangeably on Earth. But once you go up the mountain, the weight will be lower because of less effect on by the gravity. But the mass will always remain the same. The mass doesn't change due to gravity. So how they define the mass? So they use a water, 1 cm cube of water at 4 degrees Celsius will have the mass of 1 gram. Okay, but 1 gram, if everybody take the water and weigh, then it's very difficult because you must measure 1 cm, 1 cm. It's very difficult. So they have this created this bar, platinum iridium bar of exactly 1 kg. So this is a standard weight. Everybody will take reference from this because this bar also limited how many pieces you can make. So they have 6 copies of this bar, and then the 8 working standards and 2 additional copies for other use. Out of these 8 working standard, then they produce many more, and from that many more they produce even more until now you have a weighing machine and all these things. But if you want to calibrate, then you need something of a reference to calibrate. So a spring weighing machine will measure the weight, but the balance like those a balance weight with a stake, and they put a weight, let's say 100 gram, they put on one side, and then they move the string with a horizontal stake, and they move the string until the weight balance. If it's a balance, because they have a counterweight there, that measure the mass. If you measure it, let's say 1 kg, you bring up the mountain is also 1 kg. You bring to the moon is also 1 kg. Whereas if a spring loaded or those bathroom scale where you stand on it and then you measure your weight, if you stand on the bathroom on Earth, you get a certain weight, but that is equivalent to the mass close to. But if you go to the moon, then it will become lighter already. And if you go on top of the mountain, it will be different from on the floor, on the ground next to the sea. So that is the weight and okay, so and the weight comes in gram, and the same standard milligram, microgram, nanogram, and so on. And heavier normally kilogram, then higher sometimes they call ton. 1 ton is 1,000 kilogram because easier to use but they try to spell differently, like TONNE, and the Imperial one they call TON. But nowadays people don't care 1 ton is 1,000 kg, easier to use. And if you use water, 1 liter is 1,000 cc, means 1,000 centimeter cube. Is a short form of cc. So 1 liter is 1 kg. So 1 meter cube of water means you get a container 1 meter by 1 meter by 1 meter. You put the water in, it weighs 1 ton, 1,000 kg. So it's very easy to work. If you use a Imperial system, it's very difficult. How heavy is 1 ton of water? How much is 1 ton of water? What's the volume? So it is difficult to calculate. And then sometimes you use a water pump, they come in how many gallons per minute. Then you say how many gallons? So gallons, and then you measure your water tank. You measure what in cubic feet. Then how many minutes to fill up? You don't know. But if you measure in liters per minute, And then you say, oh, 2,000 liters per minute. Then you say, oh, this tank is 1,000 meter, 1,000 liters. So, okay, you take 2 minutes to fill up. No, 2 minutes, sorry, 2,000 liters per minute, half a minute to fill up. So it's very easy to calculate like that. So for all things, metrics somehow it makes life easier to calculate. But the US will still not haven't migrated over. The next one is electric current. Electric current is the measure of the amount of charge flowing through the wire per second. So this current is measured in ampere. Okay, of course the symbol is A. Ampere is the name of the person, one early scientist who study all this electricity and all this. So they name after him. So electrical charge that flow per second. So you have more current, means more electron charge flow per second. So that is a measure of current. So current is very important because it measures the charge per second. So the second is very important. The second is the time, is very crucial. Based on this time, you can measure time accurately. You can measure the current, and then the current, from this current we get many things like magnetic flux, electric field, voltage, resistance, inductance, capacitance. All these are defined based on the current flow and how much charge you can pour into the capacitor determines the capacitance, and charge means how many amperes flowing for how many seconds. You see, so the charge is measured in coulomb. So is in 1 second, 1 coulomb is 1 ampere. It's very straightforward. Of course, for us, how you measure charge is it's just something you can't see. How you measure? Of course, this is not the topic today, but very easy. You want to measure current, you buy a multimeter, something like this, and then you can measure current already without knowing all those things like charge and all these things. So those are for scientists. For us, we only measure the current and the voltage and maybe the resistance. Resistance, normally we measure is open circuit and short circuit. Make sure the wires are connected or not connected. That's all. So for layman, we're only interested in current. And when you use the 3-pin plug, there's a fuse inside. You put 13A, means 13 ampere. That is about the maximum for a 3-pin plug. Because if you use the 2-pin, okay, 2-pin plug like this, there is no fuse. So they don't need a fuse, they don't care. So if there's a short circuit, there's a trip, the main trip. Whereas if there is a short circuit, the fuse blow for our case. Okay, so and then if you use a computer 3-pin plug, if you can open up and check the fuse, sometimes it's 5 ampere, sometimes it's 10 ampere. It depends. So they are not exactly the same current rating. So if you use the cable with the 3-pin plug and use it for water heater or your kettle or your rice cooker, the fuse will blow straight away. You plug on, you blow because it exceeds the current. Okay, so it's good to know what's the ampere of your 3-pin plug before you use. For a computer, 5 ampere, 10 ampere is more than enough because your computer has very low power, maybe 1 ampere only or less. Okay, now next we come to temperature. So temperature, in the definition they call Kelvin. but they also use Celsius. So the olden days we call it centigrade. That centigrade it was confusing for some European countries because they use centigrade for other things, and then they get confused by the word centigrade and temperature centigrade. So they all settle with the word Celsius. Anyway, it starts with C. So when you put degree C, everybody know whether you call centigrade or Celsius, it's the same. So people just call Celsius, and then it sound more high class one. Like, oh, we are very advanced, we are knowledgeable, high class. We call Celsius. Okay, but what's the difference between Celsius and Kelvin? Okay, because Celsius is defined using the freezing of water. So when it's 0 degree C, water freeze. As far as layman is concerned, that's very useful. When winter, it freeze. When you go to the fridge, you open the fridge, you want to set below 0, so that you want everything to freeze. Once you set above 0, you get cold water, ice cold water, but it won't freeze. So 0 is a very good reference. There is a negative. How cold is it? Oh, freezing is -5, -10. So for the layman, Celsius is very easy to use. But for engineering and for the scientists, they need to work on Kelvin. Okay, because when you cool everything down, all the gas become liquid. But if you extrapolate the line, as you cool the gas, you can never cool below -273.15 degrees C. You can never go below that. Even you go to outer space, the extreme outer space, you can never reach this below this. But this is called absolute zero, when there's no energy at all. Zero energy, nothing move. It is not possible. Because when you cool down the gas become liquid already by then. So 0 Kelvin is considered absolute zero. So, and centigrade will become 273.15 Kelvin. It's just a reverse. Okay, so of course, in defining the temperature, they don't use the freezing of water because that is very troublesome. You want to freeze water, it depends on the air pressure in the atmosphere, so, and many other things. So it's very difficult to measure the freezing of water. So in definition, they use the triple point of water. That is the temperature where water become ice and water and gas at the same time. You can just switch over to any of these three forms. That's why they call triple point of water. I mentioned about that some time ago about freeze dry. When you want to freeze dry your food, you freeze it, and then you go through this stage at the triple point of water, where the ice become gas, and then the gas escape, then your food become dry. Okay, so that is the triple point of water. That point, scientifically, you will not run away. So that one is about 0.1 degrees C. So that is a better definition for temperature. So they use that plus 0 degree Kelvin, and then they from there on they can get the temperature range. Okay, so they don't need to keep anything to measure temperature. You can't. Your temperature keep changing. Another important scientific discovery is the mole, which is measure the amount of substance. So 1 mole oxygen will always contain 6 times 10 to the power 23, or this one is 10 to the power 23, not 10 to 3. Later I'll change it. 10 to the power 23. So it's a lot of zero behind. So this one is amount of oxygen atoms. Okay, and then one more of nitrogen will also contain the same number of nitrogen. Okay, times 10 to the power 23 means 23 zero after that. So it's 6 0 2 2 1 4 1 7 9 0 0 how many zero? So it's not the this decimal point haven't end yet. So it is very important in chemistry. So when water is H2O, that means you get 2 more of hydrogen and 1 more oxygen. You get water exactly. No more additional hydrogen, oxygen wasted. So in chemistry, you measure the weight. So hydrogen, 2 more hydrogen, let's say you get 2 grams. Then oxygen, you see what's the atomic weight of the oxygen. Then you measure how many grams. And then you mix them together and you will get a perfect chemical reaction. Okay. So next we come to the luminous intensity of a light. So they use candela. Candela, even in layman, we seldom use. But this candela is fixed. You can't change because it is measured at 1 meter away. When you take a light source, let's say a LED light, and then you measure at 1 meter away, and that is the luminous intensity, how many candela. When people talk about candela, means they measure at 1 meter away. So it will be correct wherever you go because it's always 1 meter away. Whereas lux is the intensity at the location. The light source may be 1.5 meter above your head. It could be the sun, millions of kilometers away. But you get the light intensity. So that is the measure of light intensity at this point. You put your lux meter, you measure on your table, you get the lux measurement maybe 400 lux. Then you bring it very, very close to the light source, then you may get 1,000 or higher, maybe 2,000. You put very, very close, you get even higher. So the lux is the intensity. Where you measure, that is the intensity. So lumen is the amount of light. How much light fall? That's all. For example, if you buy a light, LED light, they tell you how many lumen. Means this LED light, when you turn on, it gives off how much light. Okay. For example, okay, you buy a T8, the LED tube, they give you 1,600 lumen. So it's the amount of light. But of course, sometimes they put the diffuser and all these things, then you can go off already. But it's the amount of light that is given off. So the higher the lumen, the better. So if you buy a light, you want it to have higher lumen, but it won't translate to higher intensity. Then if you put a reflector, then you concentrate the light to a single source, single point on the table, then you get increased brightness. That's a lumen. That lumen become per square meter become lux. So you have a light meter, or you can use your phone. You download the app called maybe lux meter or light meter, or whatever you call. There are a few names like that, and then you can measure the light intensity on your table or anywhere. So you put under the sunlight, it can reach 50,000 lumen. No, lux, 50,000 lux, or even 100,000 lux under the sun. But at home, is only 300 lux, 200 lux, it'll be good enough. But sometimes office, some people will prefer higher, like 400 lux, but it's very bright. 400 is quite bright. We can work with 200 lux comfortably. Okay, so lux is a measure of brightness. Lumen is a measure how much light you can get out. You put nearer, then you got more lux. So you focus it to a single point, then you get very bright. You got very high lux. So you always want to buy a light that give you more lumen, but with less watt. What is the power consumption? Means how much energy is consumed per second. So every second you use up energy. So of course you pay in terms of a kilowatt hour. They charge you like 25 cents per kilowatt hour. But if you have a light that has a lower wattage but with the same lumen, then you are more efficient. Then you pay less money. Okay, then when you buy light, you also must look at the color. You want yellow color, you get 3000 Kelvin. Kelvin is the temperature. But why light got temperature? 3000 Kelvin is very high. See, it's almost like 3000 degree already, degree C. Of course, you less 273 lah, so it's 2700. But because it's already so bright, they just round the number up. It doesn't make any difference. But why they put Kelvin? Because if you take a rod, let's say a metal rod or what, you heat it up to 3000 Kelvin, then you get yellow color. So that's why, okay, 3000 Kelvin means yellow. But LED, you don't need to heat up until so bright. It's not like an incandescent bulb. You must heat up very bright, very hot, then you get the light. But LED, because they are semiconductor, you can get the light without much heat. And if you look at the firefly, you can produce light but no heat. So that is the ideal light source. So if you want white light, then you get 6000 Kelvin. Now you want somewhere in between, then it'll be about 4000 Kelvin. So Kelvin is the temperature, or they call color. So that is the equivalent to heating up a piece of metal to that temperature. Then you get that color. So that's how they define the color. Okay, basically I have come to the end of my talk. Now we can open for question. Then we shall stop the recording now.